Thank you once again for watching my video. My name is Mr. Charles Wenikin. In today's video tutorial, we will be discussing on FET Transistor Theory. I know some of you have not heard about this kind of topic before. I also believe that some of you have an idea on that, but today's video will be discussed on that FET Transistor Theory, the theoretical aspect of it. But before we proceed on that, please, I would like to say, please, if you like my video, subscribe to my channel, comment, like, and share. So in today's video, just as I said, we'll be discussing on FET Transistor. So in that case, we'll be specifically be discussing on the basic aspect of it, how it works, what are the things that are involved in terms of FET transistor, and types of FET transistor, and why is it called FET transistor, and also voltage device as well. So these are the things that we will be covering in this video. So let's proceed at once. So basically, the FET transistor, abbreviation FET, have three terminals. We all know that it has three terminals. They are gate, drain, and source. I repeat, basically the FET transistor have three terminals. They are gate, drain, and source. And another thing I also want you to know, types of FET transistor. Basically, there are two types of FET transistor which I know. If it has any other one that you know, you can also comment below as well. So these are the one that I know in about FET transistor. The number one is junction FET transistor, and the second one is isolated gate FET transistor, or you can also call it metal semiconductor FET transistor. So any of them can be called. Any one that you prefer, that you can call it MOSFET or IGFET. That is the same thing as an insulated gate FET transistor. The other one is metal oxide semiconductor FET transistor. So that is the actually two basic types of FET transistor, and I am also going to give you the diagram so that you will see exactly what we will be discussing today, specifically based on the tree diagram of the FET transistor. For the connection in the circuit, we also consider fourth terminal. For the connection of the circuit, we also consider fourth terminal, and that fourth terminal is basically base, or is called base or substrate. You can call it base or substrate. So in that case, the FET transistor have control on the size and also shape of a channel. I repeat what I just said before because I want you to understand what I'm saying in terms of this FET. I say for the connections in the circuit could be in terms of electronics, motherboard, our television, our handsets, our cell phones, our laptop, our printers, and even AC which we also use in our various offices. They are all used. FET is in terms of using it, it is considered as in terms of connection in the circuit, it is added as a fourth terminal called base or substrate of the FET. So the FET transistor also have control on the size and also the shape of a channel between the source and the drain, which is created by applied voltage. It was created by applied voltage during the process of current passing through it. So in that case, we move forward. The FET transistor are uni-bipolar transistors. I repeat, the FET transistors are uni-bipolar transistors because they perform single channel operation. Because what they perform single channel operation, and that is why it is called uni-bipolar transistors, because of their performances. It is single channel operation. The FET transistor have high current gain than BJT. You know, BJT, there are two types of BJT, NPN and PNP, which we have discussed it previously in our last video. We discussed on that as well, and I believe if you have not watched it, you can as well go to my channel, Charles Electronics Tutorial, and watch it. So in that case, the question is, why is it called FET transistor, and why is it called voltage control device? So this is another aspect of it. This is the reason why it is called a FET transistor, and it is used the voltage that is applied to their input. This is the reason why it is called FET transistor and also voltage device control. It uses the voltage that is applied to their input terminal and call the gate to control the current. Remember that the voltage that is applied to the input terminal is gate. It is called the gate to control the current flowing through from resulting in the output current being proportional to the input voltage. So that is from what I just said now. What I'm trying to tell you is this: that the voltage enter through the input terminal called the control and called the gate to control the current flowing through from the result in the output current being proportional to the input current. You know what proportional we have in mathematics? We have directly proportional and inverse proportional. It means that directly proportional simply means they are facing each other. They are facing each other. Let me put it in that form. So that is to tell you that both the output and the input, they are directly proportional. It means they are facing each other. That is in terms of normal to layman understanding. That is, it is called just facing each other. So in that case, as their operation relies on electronic field, you know, majority of anything based on transistor, it have to rely or depend on electric field, and you know what that means, electric field, and the name field effect generated by input, by what? Input gate voltage. Do you get that? That was where the name were generated. It is because of the electrical field in which all of them, those electronics components, pass through. Most importantly, the FET transistor in which it passed through, and that was where the name came out from. It is where it is from that place which is generated by input gate voltage. This makes the field FET transistor a voltage operated device or voltage operation device, any of them that you can call it. So that is the reason why it is called FET transistor and voltage operating or operate device. It is because of, since they are using electrical field, definitely the electrical field, which is the one that once it goes through the transistor, it passes through the gate. From there, the gate in which it passes through, it generates what we call field effect. So from that field effect, and that is where we now observe or understand that the basic function of it is to since the input is control and they are directly proportional. That was the reason why it is also called feed effect transistor and voltage voltage device control. Okay, let's also move forward. Another one here is feed effect transistor can be made much smaller than an equivalent BJT. BJT is bipolar junction transistor, which I told you that it comprises NPN and PNP, and we have discussed on that NPN and PNP, and I have also given you the difference between NPN and PNP. So in this case, the feed effect transistors can be made much smaller than equivalent BJT transistor, and along with their low power consumption and power dissipation makes them ideal for use in integrated circuits. These are the reason why they are used in integrated circuit, which is called IC. It is because of the low power consumption and the power dissipation and aspect that makes them to be used in integrated circuit, being IC, such as CMOS battery or CMOS, and that CMOS will normally it is found in our desktop, in our laptop, in our majority of our electronics gadgets. CMOS is there. It has its own specific function as well. So in that case, so as CMOS of digital logic chips, CMOS majority of CMOS it is used in digital logic chips. It is no longer in analog form. We are now in digital aspect of it, and that is the reason why it is used, because of the low power consumption and the power dissipation. So those are the things that you should also know about feed effect. Feed effect transistor have the following. Feed effect transistor have the following. One, they are highly efficient. They have high efficiency. And two, they are instant operation. Secondly, they are instant operation. And thirdly, they are robust. They are robust as well. And fourthly, cheap in most electronic circuit. They are cheap in most electronic circuit and electronic circuit application to replace bipolar junction transistor in terms of that, because bipolar junction transistor is their cousin, is feed effect transistor cousin. That is what I said. So I know why I say that. Bipolar junction transistor being NPN and PNP, which I gave you the meaning of NPN, negative, positive, negative, and positive, negative, positive. I explained that in my previous video as well. So that is to tell you that in the absence of the bipolar transistor, feed effect transistor can be used to replace the function of bipolar junction transistor. Feed effect transistor are also two basic classification. There are also two basic classification of feed effect transistor. The number one is N channel feed effect transistor, and the second one is B-channel feed-in-FET transistor. The feed-in-FET transistor is a three-terminal, which I have already said this before. It's a three-terminal device that is constructed with no PN junction. It is a three-terminal device that is constructed with no PN junction terminal within the main current carrying part between the drain and the source terminal. So that is to tell you that in terms of feed-in-FET transistor junction or feed-in-FET transistor, it doesn't involve PN junction, and that is the most important thing you should also bear in mind. I believe that you are getting what I'm saying, because the feed-in-FET transistor is a three-terminal device, which I have said this. I want to repeat what I say, that is constructed with no PN junction. In that is what I'm saying here is feed-in-FET transistor. It doesn't have any PN junction on it within the main current carrying part between the drain and the source terminal. So this terminal corresponds in function to the connector and the emitter respectively of the bipolar transistor. What do you understand by that? What I mean is this terminal corresponds in function. That is to tell you that what I'm trying to say is, instead of in terms of BJT, where we use emitter, connector, and base, here it is substituted in source, drain, and also gate. So in what I am trying to explain here is this terminal corresponds in function to the connector and the emitter respectively, which means they take the position of connector and emitter in terms of their specific function. I believe that you all understood what I mean by that. So in that case, the current part between the two terminal is called the channel. The current part between the two terminal is called the channel, which may be made of either a B-type material or N-type material. So these are the things that you should also put in mind. Remember that I said the feed-in-FET transistor theory is all about the theoretical aspect of how it works and why is it called feed-in-FET transistor, and so on and so forth. So in that feed-in-FET transistor, I told you that it has B-type material and N-type material, in which these two, the current part between these two terminals is called the N channel. The current part between the two terminals and the two terminal is called the channel, which may be made of either a B-type material or an N-type material. So in that place, material semiconductor. So the feed-in-FET transistor has one major advantage over its standard bipolar transistor, being BJT. It means that BJT, which contains NPN and PNP. What I'm trying to say here is this: the feed-in-FET transistor, it has one major advantage over its standard bipolar junction transistor, which is the cousin, in that their input impedance is very high. Their input impedance is very high. It's up to thousands of ohms. It's up to thousands of ohms. This very high input impedance makes them very sensitive to output voltage, to input voltage. So in that case, signal to input voltage signal. So in that case, both can be easily damaged by static electricity. You know what static electricity means that we have dynamic and static electricity. Anything that involves dynamic, which can be changed from the other frequency to another frequency, but in times of static, it remains permanent and remains constant the way it is. So that is the reason why it is called. That is the reason why that is another disadvantage of this feed FET transistor, because of the input voltage signal. Because according to what I just said before, it has high input impedance, make them very sensitive to input voltage signal. And notwithstanding about that, another negative aspect of it is it can be easily damaged by static electricity. Maybe in our next video, I believe that we will be discussing an important another topic that says the general. I think the general. Should I say the general of electronics, how it works. That video, I will also make the video because it has been prepared. So in that case, this is where I believe that we'll be ending of this feed FET transistor theory. I believe if you have anything to say, or you have something that I have not said before, you are expecting me to say more than what you have heard, you can also comment below. Let's see how we can resolve anything that you said, or anything that is necessary to be putting in place. And that is the reason why I'm making this video for you and for every individual who is interested in electronics, to understand the basic aspect of it and how it works. So in that case, I would like to say, please, if you like my video, subscribe to my channel, comment, like, and share. Thank you once again for watching. See you next week.